So today we will continue difficult ground condition, we will continue discussion about difficult ground condition, and this part of lecture will be devoted to cause, fusion, etc. Furthermore, we will discuss earthquakes, regions, and seismicity of construction sites. So first of all, we will start from uh, the effects on surface which can be caused by karst and subfusion. Karst and subfusion, it is a difficult ground condition which are connected with influences of water. And in this case, we can see the results of that impact of underground or surface water. In some cases, it can dissolve ground, which can lead to sinkholes, as you can see on those slides. Various kinds of sinkholes can be found at the construction site. Not only on the construction site. Sometimes such sinkholes you can find in the middle of the road. You remember in Odessa, such cases are really common when cars falls down into the underground sinkholes, and those sinkholes connected with underground technical waters because of the holes in water supply pipes or heating supply pipes. That water dissolves ground, which lead to such sinkholes as we see on this slide, on this slide. So it's a solution sinkhole, and in some cases it can lead to such a result as collapsing hole. Also, we can find such result of sinkhole. In each case, we have to strike with water because water lead to such effect as karst and subfusion. And karst, it is the geological process from dissolution of soluble rocks. This process looks like when we see the dissolution of the tablet of vitamin C or other vitamins in water. It's a chemical process which leads to sinkholes, as you can see, and on this section. And on the surface, you can find, in some cases, you can find such result of surface water, which is connected with karst also. So this process is connected with the dissolution of soluble rocks. It's a chemical process. From the another point of view, we can find subfusion. What is subfusion? Subfusion, it is also geological process, but we can find the subsidence of sinkholes or lines which are formed by particles which are eroded by the water flow. So in this on this slide, you can see the result of this water flow. So in this at this slide, you can see the direction of water flow, and this water flow displaces the little particles of ground through the bigger particles on ground, and this process is going till we can find this situation where large particles of ground are separate from each other, and in this case we will find out the sinkhole under such under such difficult ground conditions. So, in all the cases that we have discussed previously, like subsidence soils or water flow or surface water flow. In all those cases, we have a deal with water. But when we're talking about karst and submersion, in situation with karst, we are working with dissolution chemical process, and when we talk about submersion, we have a deal with we have to work with also impact of water. But in this case, it is physical impact of water, uh, relocates the small particles of water between the bigger one. So, is it clear, or any extra explanation?
Everything is clear as I see.
Okay. So next thing that we have to talk about, it is a classification according Ukrainian building codes, and according to Ukrainian building codes, we have six levels of classification. Uh, this level measures in amount of karst sinkholes per 1 square kilometer per year, and the worst case of karst is more than one sinkhole per year per 1 square kilometer. And also we have another classification which is connected with the diameters of sinkholes, and the worst case is the sinkholes with the diameter more than 20 meters. So when we have to work on such construction sites, we have to aware of those classification of those situations. So try to not design on first category of cars, and on the category with the cars the diameter more than 20 meters, because it is because the building that you will design will be so expensive. It will be really expensive, because you have to uh, dig underground the biggest part of your budget of the budget of your building, because all those problems which are connected with the water influence, with underground water influence, are really expensive. You have to solve the geotechnic exercise, so to solve that problem. So, and you can see the result of submersion, or in this case it is connected with the underground water flow, and it's natural water flow. And in this case, we have a deal with technical water flow. And you can see this team over here. So it is a result of heating pipe destruction. So, and in this case, we have a deal with hot water, which made such a big sinkhole underground. And what do we have to do when we are working on karst or submersion hazardous territories? First of all, we have to work with correct planning. We have to protect our surface from collecting of water, because all collected underground above ground waters will move underground and make their deal in case of karst hazardous territories. It will dissolve our rock structures, rock underground elements, and in case of submersion, it will make water flow, which removes small particles of soil between the biggest one, and that will also lead to the sinkholes, to the underground sinkholes. And next is waterproof and anti-filtration protection. It can be different mm, it can be different geotechnic structures, which we will discuss furthermore. Also, it is geotechnical solutions like strengthening of foundations and strengthening of ground. In some cases, we can use such technology as jet grouting or even ground cement piles. It is a mixture of the ground with the cement, which leads to anti-filtration wall, underground anti-filtration, which can create underground anti-filtration wall. Various constructive or structural solution, also technological solution, which can protect our pipes from water leaks, and also operational, so correct monitoring, which can also protect our grounds, our soils from impact of water leaks. All those solution can guarantee proper work of our soils when those soils are protected from destructible impact of water, of underground, and also surface water, and also from surface water. So next, water protection anti-karst measures, which we will discuss, they include vertical leveling or vertical planing, so to protect our surface from collection of water. Also, measures to prevent leakage of industrial and domestic water, especially aggressive water, because when we talk about karst hazardous territories, though those hazards can be connected with not regular water, but with water with some aggressive dissoluted elements in that water. And also, we have to prevent the accumulation of surface water in pits and on the site during the construction period. So we have to protect our ground from collecting of water, which can leak underground and create such underground caves and sinkholes. Also, there are some structural geotechnical measures which can include plugging of karst cavities. So if you have such underground cavities, such sinkholes, we can plug them with cement or concrete, or even with sand or other filling materials. Also, we can use methods of consolidation of those karst rocks, and support a foundation on reliable non-karst fixed soils. In this case, we can use piles which comb through those underground sinkholes, and which are supplied on reliable fixed solid soils. So to use piles that comes through those karst or submersion sinkholes. Also, we have structural measures such as special design solutions of foundation, and to make the above ground part of building more rigid by adding some floor belts. It's various elements made of steel, and also space frames, which includes the rigidity of design building. So that's all about karst and suffusion. So to sum that part of our lecture, karst and suffusion are both connected with impacts of water. And main difference between karst and suffusion that lies in that. In next, karst, it's a result of dissolution of rocks with underground or surface water. And when we talk about Suffusion from the significantly differs from karst, because in Suffusion we don't have chemistry, we have only a physical process of a water flow which replaces little particles of soil between the bigger particles of soils, and which can lead also to sinkholes, to underground sinkholes of big diameters. And those waters can be connected with various causes. First of all, it can be surface water, rainwater, or even underground water of natural creation, or maybe it can be connected with underground water which are connected with various pipes and links which are located underground and have leaks, which leads to creation of such cavities, of such underground sinkholes. So next difficult ground condition that we have to discuss called abrasion. We have seen big amount of abrasion impacts on this weekend because of the storm that we have seen on our Black Sea. And this storm led to a destruction of some seaside structural elements. It replaced various concrete elements which was prepared to protect our seasides from the impact of such storms. So this storm was so strong that it has replaced a big amount of such protective structures. So what is abrasion? Abrasion, it is not the result of dissolution, as we talked previously about karst. Abrasion is the process of the sea or other or maybe ocean which eats our seaside. It bites day by day a little piece of our seaside and destroys it. And you can see the result of those abrasion impact on the seaside structures. We can see various elements which were beaten by the impacts of sea, or by the waves of sea, or in some cases it may be the ocean also. So this leads to reduction of our seaside, and it is really necessary to protect our seaside part of territory from those impacts. And what do we have to do? First of all, we have to use various wave protection solutions. And when you walk through our big fountain, when you're talking about walking about through the seaside of our sea, you can see a big amount of along coastal retaining walls, sheet piling walls, or other structural solution which leads to protection uh, of our seaside. Also, dumping wave energy elements, which reduces the impact of water strikes. Some of them can be alongside, some of them can be sloping, but all of those solutions leads to reduction of the energy of all waves. And also beach restraints elements along coastal elements, which leads also to protection our seaside from the impacts of the sea. So when you see on our seaside sand, a big amount of sand, it's not uh, for the rest of the people. It's not in from the first from the main point of view. It's not for the people. It is to protect our seaside from the impacts of the waves. So our Odessa sand beaches and other sand beaches, because sand beaches are not natural for our city. Natural for our city. Big stones of limestone, big parts of limestones, as you can find in uh, at our beach, like Yellowstone, big Yellowstone that you can find uh, on Azarova Street. There is big Yellowstone. It's a part of our seaside of our bank, which replaced it by sea. So in most cases, that parts of our seaside those parts were replaced by waves, and you can see the result of them. So in our goal to protect our seaside using various structural solution that can reduce the impact of waves on our seaside. Next, the difficult ground conditions that we also have to discuss, and it is also really important for Odessa, because when we talk abrasion, cast of ocean, all of them can be at our construction sites. And also, when we talk about landslides, they are also really dangerous for our buildings. A big amount of landslides have taken in our city, and our main goal to protect our seaside, seashore from those effects. But when we talk about this situation, we have to know that landslide protection is a really, really expensive solution. Uh, and by the way, we have to know that the most expensive real estate square meters are located on landslide territories, because landslide territories in Odessa in most cases are located near the sea, and that is why sea view is really expensive, and that is why the buildings which are located on those soils, on those landslides, are really expensive. And that expensiveness can be subdivided on two parts. So first part, it is the payment for the sea view for the buyer of those square meters, and next part is the amount of money that he have to pay for the protection from landslides. So what is landslide? It is also can be called landslips in some foreign literature sources. It's some several forms of mass which are weighting that may include a wide range of ground movements such as rockfalls, deep-seated slope failures, and mud flow, and also debris flows. All those effects you can find on Odessa seashore. So that is why I'm returning to our first lection about difficult ground condition. Odessa is the combo of various difficult ground condition, and in some cases not even two or three. In most cases, it may be four. Sorry, sorry. It can be four or even more difficult ground condition. So it can be combo of seismicity, landslides, underground water, or even subsiding soils, or karst or subfusion. And though and we have to may have a deal with such amount of difficult ground condition, and to use combo of structural or geotechnical solution to protect our building from effects of those difficult ground conditions. One more landslide photo. And what leads to landslides? So first, the landslides causes are connected with the impact of water, all those causes can be divided on two main groups. First, that those that lead to a change of the straight state of the rocks or a slope or slope. It can be connected with various external influences like overloading. So it may be additional loads which can be connected with microseismic or seismic or other vibration, and also we can differ next significant group which lead to decrease of the strength of the rock falls, and also those strength reductions can be connected with moisture or other strength reduction causes. So next, what I wanted to tell you about landslides, it's measures. So in most cases, landslide protective measures are connected with structural solutions. First of all, it's retaining and supporting structures and foundations. Next, it's a foundation which is streamlined by landslide masses, which catching we can catch those streams, or they can use it like an anti-fall structures and galleries. Also, coastal protection structure, drainages. One of the main problem of the Odessa landslide connected with water. So, if we will use drainages, we will be able to reduce the impact of that water and to protect our landslides from water impacts and to protect the whole territory from landslides. Also, changes of the reliefs and slopes, it is a really good solution also. Agroforestry is a really good solution and a really good and cheap solution because the roots of trees can protect our slopes from landslides because roots of trees dug deeply underground and grabs to the solid ground and can work as the good connector of not strong enough surface part of landslide with a strong underground part, and this connection can be obtained by use of tree roots of trees and other plants. Also, we can use chemical consolidation of the landslide soils and various coastal protection structures, as we talked previously. Oh, I have written it two times, coastal protection. Sorry, I have to reduce it, to delete it from here. Next. And here you can see various support walls or retaining walls which can help us to protect our territory from the impact of landslides. In all those cases, those elements can uh, save our construction site from the impact of those landslides. So here you can see the curve on landslide and such massive underground retain or support wall can protect our construction site from the impact of those landslides. Also, the shape of that retaining wall or support wall can be like this. In some cases, we can use such piles and retaining wall and the combo of those solutions. We can use these massive walls, and in this case, you can see the exchange of the ground. So we are creating such retaining or support wall, and the rest of the ground we can fill with the goods with good ground. Also, we can use not. It is not necessary to use reinforced concrete walls. Those walls can be also made of masonry. Masonry, it's like bricks. There's in most cases all retaining walls which was built or even 200 years or even 100 years ago. They were built from limestone bricks, and those limestone retaining walls protects our slopes in the old part of our city. In some cases, we can use such anchors. So here is the retaining wall. Here we can see underground anchors which are produced by using this special technology like Titan or other technologies. And these underground anchors connected with these on-ground element, and this combo of elements can protect us from this landslide. Also, such piles and anchors also can be used to protect our construction sites from the impact uh, landslides. And a special picture for the Odessa landslides. In Odessa, as we talked previously, we have to struggle with the combo of problems, and here is the solution. So, first of all, to protect our landslide from impact of water, we have to make such elements. Oh, I have forgotten how to be latok. Tray. Yeah, to use tray like this. This tray can grab the water which previously was going on this slope. So grab the water at this tray and collect it in such a vertical drain. And there, in such elements, you have seen such elements on the Odessa seaside. It can be collected and removed to the Black Sea. Also, to reduce the weight of this slope, we can cut this part of the ground. This is also a solution. Retaining wall, sand beach, and this sand beach also protects us our seaside, and also anti-abrasion reinforced concrete retaining element which protect us from the strikes of sea waves. And though that collection of solution can protect our Odessa seaside part from the landslides. So and now, is it clear about the landslide, or do I have to add some extra information?
Generally, I understand.
Okay, that's good. So next, we have to unite all difficult ground conditions by considering the effects of those ground conditions on our building. So next part of our lecture will be connected. How do we uh, have to examine the existing buildings, and what causes can lead to such problems as we see on those slides. So in some cases, we can find on the building these kind of cracks, these kind of cracks, these, or even these. And all those cracks can be connected with difficult ground conditions. So in some cases, like a new building, new multi-story building that is built near the existing old building, we know all those problems when we are starting to such construction near the old building with big cracks, which have big cracks already. So that building, because of its weight, leads to significant settlement of this ground, and this settlement also leads to settlement of ground in this part, and that settlement gives us such cracks and even destruction of such building. So new big multi-story building can destroy old buildings which are located not far from all this. So in such cases, we have to make a special structural solution like pipeline. Piles or other wall in ground solution, and it's like a little examine. So when you see such cracks in building, what difficult ground condition can lead to such cracks? So we in the on this stage we exclude the impact of multi-story building, new multi-story building. So we have examined the territory, we haven't found a new multi-story building, and we have to make a suggestion what difficult ground condition can lead to such crack. So you have the information about the whole amount of difficult ground condition. Please tell me what difficult ground condition can lead to such crack.
Subsiding soils.
Yes, subsiding soil. So, yeah, next.
Undermined areas.
Yeah, undermined areas also can be located under the part of the building. Yes, next.
Landslides.
Oh yeah, maybe landslide if we have landslide over here. Yeah, or maybe if we have a landslide over here, it can lead to such cracks also. Yes, next.
I'm not sure, but maybe sometimes flooding can like destroy
Yes,
the
yes, local
foundation.
flooding. Yeah. Local flooding also can lead to such destruction. Also, karst fusion it also can lead because such cracks may be caused by underground sinkholes, which are connected with karst or fusion difficult ground condition.
Mhm.
Okay, next this. So
Mm,
yeah, I absolutely understand that it's impossible to have a sinkhole under the building, under the center of the building. So that's why we can exclude karst or submersion sinkhole under this building. Such case can be connected with impact of water. What kind of impact do you think in this case?
water tables uprising.
No, water table uprising leads to overall deformation of building. Maybe in such cases, but I don't think so.
Mhm. Um, Actually, like in Odessa, it's also can be like undermined areas where we have
Yes,
catacombs, and this can be
maybe
parallel.
it's really hard to believe that our building is erected overall on the undermined territories. No, let's take this version. Okay.
Mhm.
Why do I'm asking this question to you? Because you as an architect, you will have a deal with such problems, and in all those cases, you have to make the analysis of ground. So you have to make a contract with geologists, and they will make a report on the result of of those boring analysis. So they making bores, and those bores shows them the information about the layers of ground which are located under this building. But first of all, before you decided to make those geological condition examine, you have to know, you have to suggest what causes can lead to such deformation of building. Next cause of such problem can be subsiding soils, because
Mhm.
such deformation can be connected with the collection of uh, water on the surface, and that surface water can move underground and lead to such deformation. Okay, next case. What can lead to such deformation?
Uh, s- so we can predict that the deformation gets in the middle of the foundation or on the middle line of the foundation. So first that I can imagine it's maybe earthquakes, so seismic ground.
Maybe it can be caused by significant deformation from this and this part of building at the same time.
Hmm. Uh, so in this case, I think it can be uh, water table uprising that like take the
Maybe,
middle.
maybe. Yeah, because
And
the ground in the center part of the under the central part of the building is compressed in the more in the most level, so the compression here is harder. That is why the underground and on ground water is harder to move under the center of the building, and from the both sides it can be, it can lead to such effect also. Yes.
undermined areas.
Oh, but in this case, we have one undermined area from here and another mine from here. So, no, it's hard to believe, but maybe, yeah, maybe. Next.
Maybe. Um, cards or suffusion.
No, karst or subversion. I think that's impossible to make those subversion or karst effects in the same time from both parts of the building. But maybe, maybe. Okay. So here are the main problems which can lead to such effect of the for the building. So next part of our lectures will be devoted to seismology, and we will discuss all problems which are connected with architectural of earthquake engineering. So first of all, for to start the seismology, we have to know that we have different levels of seismic hazard. There is global seismic hazard for the whole world, and later we will consider our local seismic hazard, local Ukrainian seismic hazard. So first of all, when we analyze the whole territory of our planet, we have to admit that only 10% of our surface is located in earthquake hazarded territories. But the situation is next, that on those 10% of territories lives more than 50% of our population. Also, we have to know that historically earthquakes was near us. Earthquakes were near us, and analyze of world's seven world's wonders give us an ability to understand how dangerous earthquakes was for the were for the for our parents. Well, first of all, it's Lake House in Alexandria. It has a great height of more than 120 meters, and it was destroyed by earthquake. Next is Mausoleum in Halicarnassus. It also was destroyed by earthquake. And next, it's Colossus of Rhodes. It is all was also destroyed by earthquake. Next, three world's wonders were destroyed by fires. Temple of Artemis and this statue in Olympia were destroyed by fire, and the Hanging Gardens of Babylon were destroyed was destroyed by flood. So 50% of world wonders were destroyed by earthquakes, and we have only one world wonder which survived till our days. It's in Egypt pyramid, and that element is exist until our days. And a main idea why do I decided to consider those world wonders that lies in that you have to know that the form of the building is the main earthquake engineering solution. Form of the building is the only like almost 90% of earthquake resistance of structures. And when we will analyze three world wonders which were destroyed by earthquakes, you have to admit that all of them were high structures with big height. But when we talk about big height and little little flat of its connection with the ground, with little foundation, and only Egypt pyramid is have with big height also have a huge foundation which protect it from destruction from earthquake. And when we talk about local Ukrainian earthquakes, we have to know that more than 30 major earthquakes have occurred on the territory of Kievan Rus, and during the last 900 years. Some of them were even before Christ, it's 480 in Chersonesus, and in history sources we can find information that it's lasted 40 days. It's impossible in our location, it's impossible to take such for earthquake to make for earthquake to be during such big duration. It's only historical hyperbola which they use to describe significant earthquakes. Maybe one by one, maybe today earthquake, tomorrow earthquake, in a week earthquake, and during 40 days those earthquake took place. Maybe, but such earthquakes can be that's impossible to make such a long duration earthquake in that region. Also, one more 63 before Christ, zone of Kerch and Taman Peninsula. And our local earthquakes, it's 11th century in Sevastopol, in 15th century in Crimea, Kaffa earthquake, 1927 a strong earthquake, and also we have to know about Odessa earthquake, which were in 1802 and 1940. All two those earthquakes have the intensity of 6th grade, and they came here from Romania, and also we know five earthquakes with the intensity 6. One moment. So next earthquake that we have to discuss is Odessa earthquakes. As I told previously, we had two earthquakes with intensity 7. five earthquakes with the intensity six earthquakes with the intensity 5 and vice versa. And here are the sources of earthquakes in Ukraine. So first of all, we have to know that biggest hazardous earthquakes to Ukraine uh, goes to us from Romania, from Vranche area, and also Dobruja area, and Crimea earthquakes. Crimea earthquakes goes from the crack which goes through the Black Sea. And here we can see the same crack which goes to Crimea from Vranchi area from our Carpathian. So our Carpathian and our Crimea earthquakes are connected with the same crack in the big tectonic plate. Also, we have other local earthquakes which are located in Chernigov, Lugansk, and in Donetsk region. And here is the map of peak ground acceleration for the Ukraine. And you can see that in most cases we have to do something with those earthquakes which are located on the Romanian territory. And here we can see also our Crimea earthquakes. And here is the scheme of tectonic zones of Ukraine. And here the crack that I was to talk previously. Here it is. Yeah, that's a big, huge crack. It comes through the Romania territory, and here it comes from through our Odessa region and through Crimea. It's a European platform, and it gives us most problems for our country, earthquakes problems for our country. And here are those regions that I've talked previously: Crimean Black Sea region, so southern and eastern Carpathians, the Bruja region, and region of Carpathian and Transcarpathian regions, and also platform part of Ukraine that we talked previously, and Kharkiv, Chernihiv, Kupiansk, and Donetsk also. It's local earthquakes. So we have considered main causes of earthquakes, and right now we have to also to consider the causes of building destroyed by earthquakes. Though destruction connected with various errors. So first of all, it's design errors. Next, it's construction errors. Those errors that can be made on the construction side. Operating errors, it's ineffective operating of those buildings, and also destruction of buildings during the earthquakes can be connected with the errors in regulatory documents, and also it can be because of disregard for seismic hazard, because some designers are not taken into account as seismic hazards and all at all during their design. So that is why when that earthquake takes place, it can destroy the building which was not designed to withstand the earthquake. So that's all for this part of the lecture. Today, at the fifth lesson, we will continue lectures part. Do you have any question, Jan?
No.
So that's all for today. See you at 1440, and we will continue.
Okay, see you later.
See you later. Bye.